Hey everyone, this is your textbook work for March 17th and March 18th. If it's Tuesday, March 18th, okay? A day, B day. Put your name right here. This is page 79, so please find page 79. Spanish page for that. I do not know the Spanish page for that. Okay, so if you need a Spanish copy, we're looking at lesson 8. Lesson 8. All right, first thing we're going to do, obviously before you start, you should have a calculator, you should have a ruler, and you should have a crayon of some kind. Let's graph these two sets and see where they meet. This is on the test. We got our x-axis, our y-axis. And the first, when you look at these equations, the first place we want to start is the 6 and the -3, right, on the y-axis. So let's go to 6 first. 1, 2, 3, 5, 6. Put a dot at 6. Now on the one that is 6, we're going to go up 2 over 3. Up 2 over 3. Up 2 over 3. Use our ruler. Draw a line. Put some arrows on it. Next one is -3. So 1, 2, 3 down right here. And it still goes up 2 over 3. Which means they have the same slope. And we've talked about this before, but it's important to remember, same slope lines do not cross. So these are parallel. No solutions. And we can tell that just from graphing. But also look right here, same slope you can tell just by looking at them. So in the future, if you want to just see, oh, they're the same, there's no solutions. Next page. And of course, like any work we do ever, you'll pause it if you need to and do that regularly, or rewind it, or however you see fit. All your work is on the back side, so you have like front side, back side, front side, back side. But I will be jumping around, okay? And your textbook, you won't be needing it because you'll have this packet. So, but the packet's from your textbook, and you can take it home when you want. This is page 81. 81. You're just following along. Okay, you see these sets of lines? You see how they're parallel? We just got done talking about parallel lines. It's no solution. Okay, next. Go to number 2 here. Let's zoom in on 2. See how 7x and 1/7 x, do you see how that those are not the same? So they will have a solution because they will meet. But if it said 7x and 7x, then you would say no solution. Okay, let's go to this one. Do they meet? Yes. So it has a solution because it's right there. Okay, you want to go above and beyond? Tell me what this solution is. -3, -3. Above and beyond that would be to tell me what these lines are. This starts at 5, and it goes up 1, 2, 3 over 1. 1, 2, 3. So this is y equals 3x plus 5. And this one starts at -4 and goes down 1 over 3. -1/3 x minus 4. Okay, next page. Take a look here. Are these the same? Is 3x the same as -3x? No, they're not identical, which means they will meet. They'll have one solution. If they were identical, it'd be parallel lines, no solution. Okay, look at the next example. What do you guys think? I'll let you pick on this one. I'm not going to pick for you. Go to the next one. Look at the slopes. Are they the same? So I'll let you pick on that one. Number 7. What is it about a system of equations that would cause there to be no solutions? Same slope equals parallel lines equals never cross equals no solution. Okay? That's kind of what you need to know about that. Next page here. Shaniqua. Shaniqua is buying a balloon bouquet. Her favorite colors are silver and purple. The silver balloons cost $1 and the purple balloons cost 80 cents. How many of each balloons can she put in her bouquet if she doesn't spend more than $20? So S stands for silver plus 0.8 purple is less than or equal to $20. So this is S for silver, 0.8 purple. So I suppose if we were graphing this, we might want to make these go by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 2, 4, 6, 8, 10, 12, 14, 16, 18, -2, and so on. I don't think there's any negatives, but there you go. All right, so how do we figure out what our x and y intercepts are? I already taught you this. If you cover this and divide, 20 divided by 1 is 20. So we can plot one of the numbers at 20. Okay? And we can put a dot right here. S me call this a silver. And P, purple. 20 divided by 0.8. Do that real quick. That's going to be more than 20. 20 divided by 0.8. $25. So up above here, this is 24. 25 is right there. It's going to make this long line. Okay, and then, you know, we can come up with different combinations for each of those things as long as they fall on this line, right? So if there's 25 purples, then there's no silvers. If there's 20 silvers, then there's no purples. But what if you want a little bit of each, like this? So this would say there's 12 purples and 10 silvers. 12 purples and 10. Okay. And we can really just find a bunch of these numbers. Here's one. Here's 4 silvers and 20. That isn't right. Is that right? 20? 20 purples. Yeah. Okay. Here's another one we can do. 8 and 16. 8 and 16. Probably do this one. 16 and 6. 16 silvers and 6. As long as it falls on that line, okay, and it doesn't go over $20. Okay. The only thing I would do next is I would verify that none of these went over 20 bucks. So you would do like 12 times 0.8 plus 10 and make sure that it's under $20. 12 times 0.8. So it's $19.60. And then do this one too. 20 times 0.8. Well, this is $26. No. It's $20 even. Oh, wow. Well, I guess we can allow that because this line says it could be 20, okay? So 16 times 0.8 plus 8. And it looks like it goes over $20.80. Okay, so how do you fix this? Back off 1 here, make it 15 and 8. And that'd be $20 even. Okay, check the last one. See if you can see if it works. 6 times 0.8, and then add $16 to it. All right, next one. You can pause that while you figure that out. Moving on. Graph the system of inequalities. So we're going to go with -5 and -4 to start. So the first one starts at 5. This is your starting location. So 1, 2, 3, 4, 5. And go up 3 over 1. 1, 2, 3 over 1. And just for the sake of more dots, I'm going to go backwards just to make my line better. And then this one starts at -4, 1, 2, 3, 4, and goes down 1 over 2. So if I was going backwards, it'd be like this. down 1 over 2, down 1 over 2. Graph the system of inequalities to show the systems. All right, so this is the part where you need your crayon. If you didn't have one already, you have a crayon. You're going to shade, partial shade. And how do you shade? You check each step, check for origin. Check origin is making true or false statements. If it's making true statements, we shade with the origin. If it makes a false statement, we shade it away from the origin. Now we're, a day away from the test, so everyone should know how to do this, okay? And if not, maybe this will help you on a test if you need to use your notes. So 0 goes here, and 0 goes here, so it makes a statement. 0 is less than or equal to 5. True. So for the one that starts at 5, this is true, we're gonna shade including the origin. Okay, this one, 0 is greater than -4. That is true. 0 is greater than -4. So this one's gonna go up, see? And this first side over here is gonna get the same exact shade as you just did, light. Light, okay? Same lightness, right? But this region over here gets a double shade because now it's been shaded again. So when you're all done, it should look like this. Lightly shaded, double shade. Next one here. Make a graph. You should try to pause this video if you want to try it on your own without looking and see if you can do it. Now would be a good time to pause. If you don't know how to graph it, maybe I help you with that part and then you pause it to see if you can do the shading. All right, here we go. +3 means 1, 2, 3 on the y-axis. The -2x means we're going to go down 2 over 1. Down 2 over 1, down 2 over 1. I'm even going to go back 2 over 1. Just for fun, make a bunch of dots. Because they're going to meet somewhere and just, dots are cool. Got them. Next one says -4. 1, 2, 3, 4. And up 1 over 3, up 1 over 3, up 1 over 3. And it should say that one of these should actually be dotted. Hopefully you did that. This one, this first one here, the +3 is like a dotted, okay? Which I can't fix. So I'm just going to make these annoying marks to show that it's dotted, but you can make a little eraser marks if you show that. All right, so you have a dotted line because this sign means dotted, this means solid line. And do we shade left to right? Let's see here. 0 is less than 3, that's true. 0 is greater than -4, that's true. So both are getting true, which means we're gonna shade this side for the origin. And we're gonna shade up. So another light shade here, but then a solid shade in this space. See that? All right. right, so if you did it correctly, you have light shade, dark shade, solid shade, dotted line, solid line, okay? Congrats to those who can do that. Getting ready for the test. Let's try it again here. This time we have to do some division. Try to figure out how these are going to be plotted here. Make my line for this one while I'm at it. X and Y. Okay. Now, for this one, if you ever see it in standard form, I taught you the rule. You can cover up and divide, okay? So if you cover this up, 6 is being divided by -2. 6 divided by -2. So x equals -3, but you would write that like this. And then you would plot that. Where is -3, 0? Right there. And then you'd cover this one up. And it'd be 6 divided by 3, which is 2. Y is 2, but you would write it like this, 0, 2, and then you go find 0, 2 like this. And then you would graph that. And it's dotted. Both these are dotted, so I won't forget that this time. Dot, 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 dot. Next one, it's 10 divided by 5. So y is 2, and 10 divided by 2. So x is 5. So x is 5 is 5, 0, and y is 2, 0, 2. So 0, 2 we already graphed. There it is. 5, 0 is over here. 1, 2, 3, 4, 5. And it's also dotted. Two sets of dotted lines. There we go. Now we got a graph. Shade, I should say. Pause it if you want to see how your shading went. But we're going to plug in 0, 0 here, 0, 0 here, and it's going to say 0 is greater than 6. That's false. And 0 is less than 10. That's true. 0 is greater than 6. False. 0 is less than 10. True. So for the one that we did first, this first one, it's false. So we will not shade where the origin is. We will shade over here. And for the one that we shaded, this one, it's true. So we do need to shade this way. So you see how this region is going to be the double shaded region. But this region needs the same light shade that you did the other one. So it should look like this. Both dotted. Light, light, double shaded. Next. See, if you need a lot of help with this one, try now to do this one on your own. Pause it if you want to give it a shot. We're dividing here. We're doing 6 divided by 2. If we're solving for y, we're plugging that up. We're saying 6 divided by 2. So y is 3. So 0, 3, which is right here. And then we cover this up. We're saying x is -2, which is -2, 0, or right here. And we will do a solid line because of the equal to there. And now this one, we're going to divide 24 divided by -8. So x is -3, or -3, 0, which is located here. And then we're going to cover up this one. 24 divided by -6 is -4. So 0, -4, which is down here. 1, 2, 3, 4. It is a dotted line. And let's find out how we shade. Pause it here if you want to test it yourself. So 0, 0. So 0 is greater than 6. That's false. And 0, 0, so 0 is less than 24. That's true. So the dotted line is true. The solid line is false. So the solid line is going to be shaded up, not with the origin. And the dotted line is going to be shaded up with the origin, which means this is the this is regular shade. This is the double shaded region. So hopefully that is what yours looks like. Let me zoom out. You have both of these look like this. That's the idea. Now, if it's the first time you've done that and you don't really know how to do that, these are great notes. Next page. All right, just gandering. Let's gander at some word problems here. 1 week, Carlos bought 2 bags of burrito bites and 3 bags of Milo Munchies for $42.50. The next week, he bought 5 of the first and 6 of the second for this much. Based on this information, figure out the price for each bag of toffee. Okay, this is the system of equations. I believe you'll have like one of these on your test. I think, maybe more. Maybe 2. So it's giving you the equation right here. 2 of this, 3 of this is that. So that's an equation. So we'll say 2b for Brutus plus 3m for Milo equals $42.50. The next equation, I bet you can figure it out. 5b plus 6m equals 94.25. Now, this is a system of equations. How do you solve it? Well, for those of you who need a little help on this, we can cross off the m's if we make this a -6, but it's not a -6. So what do I have to multiply to make it a -6? A -2, but the -2 gets multiplied into everything. And now we have a new equation, and that new equation is -4b, because this times this is this, and -6m, which is good. That means we can cancel those. And then this is going to be, what, 85? -85? Someone needs to do that to double check, but I think it's 42 and 42 is 84. Yeah, I think it's 85. Okay. So now we're going to combine these. That's just b, because 5b minus 4b is b. And then we're going to subtract these. And I think it's 975, but we can double check. 94, 25 minus 85. Oh, 925. All right. So we know that 1 bag of Brutus bites is $9.25. And then we can plug that 925 into any of these 3 equations. I'll just go with the first one right here. Okay. 2 times 925. So I'm going to write that out. I don't have a lot of space, so I'm going to use the top over here. 2 times 925 plus my 3m equals 42.50. That was the original problem. I just subbed in 925. 2 times 925 is $18.50 plus 3m equals 42.50. We're going to take 42.50 and we're going to subtract 18.50. It's $24 even, so now I'm left with 3m equals 24. We're going to divide by 3 on both sides, and m is $8, meaning Milo is $8. So we have our answer. Each bag of Brutus is this, each bag of Milo is this. all from a systems of equations word problem. Now, if I ask you which one's cheaper, you could answer that now. We couldn't answer it before. If I asked you which one tastes better, you would say the Brutus bites. They taste better. Then you would think about it like, what? How does he know that? And it's like, wait, isn't this dog food or something? And how do you know that? So we don't know that. So we don't know about taste. So there you go. Now, I want you to try this one, Carlos. Carlos purchased 6 dog leashes and 6 cat brushes for this much. Clarita while she was pampering the pets. Later that summer, he purchased 3 additional dog leashes and 2 cat leashes. Okay, so we have 2 new equations, okay? I want you to pause it and see if you can make your own 2 equations, okay? If you can't, then don't pause it. I help you with it. 6 leashes, so we can say like 6L. And then 6, we can also say 6D, like 6 dog, and then 6 cat. That's probably what you'll do, right? 6 dog and 6 cat. But some people go, well, I did leashes and brushes. That's fine. It's fine. But I did dog and brushes. Well, that's weird, but also fine. Okay, that's $45. The next one, just make sure you use the same one. Like, don't change them. If I use dog and cat, I need to use dog and cat again. So 3 dog and 2 cat for 19. Okay. Now, if you know how to solve this in system of equations by yourself, then pause it and do it and see if you're right. If you don't know, just keep listening. I can tell you right now that I need to multiply this bottom by -2 to get -6 to cancel here. Or I can multiply this bottom by -3 to cancel here. It's your choice. I'm going to go with this one. So -2. And that's going to get me a new equation of -6D, because this time this is this, -4C, and -38. Now I'm going to add these together, cross off the D's. The C's are now, and I don't need this middle anymore because I already did it. 6C minus 4C is 2C, and 45 minus 38 is 7. And dividing both sides by 2, you get the cat brushes are $3.50, because that's what 7/2 is. You take that $3.50 and you plug it into any equation you want. You plug it in right here, or here, or here. I'll just do the top, okay? And I don't have any room, so I'm going to do that over here. So 6 dog leashes plus 6 cat brushes are $45. And notice I put the price of the cat brush right there. So now we're going to do 6 times $3.50. So this is $21. So now we're going to subtract 21 on both sides. 60 equals 24, divide by 6. D equals 4. So the dog leashes are $4. And the cat brushes are $3.50. Ta-da! Okay. Now, I'm not going to solve any more of these, but you're welcome to try. Number 4 is really, really similar to what we just did. So if you've just been paying attention, you can try it. I want you to try number 4. 5 is a little more challenging. Up to you if you want to do that one. But I would expect on the test a problem like 2, 3, or 4. Okay? All right. You can pause the video if you want to try it or not, but I'm moving on. So let's go to the next page. Here we have a system, and we're going to divide and plot and draw lines. Okay. There's no shading because you don't see inequalities. All right. So here we go. Graph's already made for us. How do you solve for D right there? You divide. You cover it up. You can solve for C right there, or you can solve for D like that. Okay. So it's 36 divided by 4. Okay. Which is 9 comma 0, because 36 divided by 4 is 9. And the dog treats are on the x-axis. That's how I know that this is x. And then this is y, because it says dog treats are where they're supposed to be. So C is 36 divided by 12, so it's 0, 3. So 9, 0, and 0, 3, and then make my line. Now divide 30 divided by 10. You get 3, 0. And then 30 divided by 6, you get 0, 5. Again, you're treating this like x and this like y. All right, so where's 3, 0? Right there. Where's 0, 5? Right here. Drawing a line. Can't shade it, but there we are. All right. You want to try this one? Pause it if you want to try it on your own. Otherwise, here we go. 18 divided by 2 is 9. 9 comma 0, which is right there. And 18 divided by 3, 6 is 3, so 0, 3. Right there. We're just graphing that line. 30 divided by 10 is 3, 0. And 30 divided by 6 is 0, 5. 3, 0, 0, 5. Graph it. Done. So hopefully yours looks like that. Try the next one and pause it if you want to try it. Okay, this is a 0. So if you don't want to, if you just want to keep watching, I'll do it for you, right? So 12 divided by 0, 0 times what is 12? Really can't. It's like, we really can't. Okay. This one right here, D is equal to 1.5. You just go to 1.5 and put a dot there, and there's nothing else to do except for draw like a straight line at 1.5. And then this next one's going to be a slanted line. 30 divided by D is 3 comma 0, and 30 divided by 6 is 0 comma 5, right? So 3, 0, 0, 5. And don't worry about this. It's fine. All right, next page. If you need to see that, pause that. If you need to see all 3 of them, because it goes fast. A little more. Pause that right there. Okay. I'm on lesson 9 at the ready. We're just doing as much as we can. Okay, obviously it's a lot, but this will give you stuff to do. And then if you need to take it home and do more over the weekend, which makes no sense because it's not the weekend. But, if you have me on Monday, you have 48 hours until your test. So you could take this home, finish it, and study for the next 48 hours. And you have the video to go with it, and it's beautiful. And yes, it's not a weekend. But spring break is coming up, and that's nice. Who doesn't want 9 days off? All right, determine if each system of linear equations So we want the solution. So this is the first problem right here. And do you see any coordinate that matches? 0, 7, 0, 4, 1, 9, 1, 9. Oh, that's the solution. 1, comma 9. Okay. How about this? Where's this solution going to be? What if you have two y equals and it wants the solution? You plug them into each other and solve for x, and then plug back in and solve for y. So this is a regular solve for x problem, one that we've been doing for a year and a half now. Okay, 3-step equation. Minus 3x on both sides, and we're going to add 9 on both sides. So just like that, we move the x to the left and we move this number to the right. So that's gone and that's gone. And what do you have left? You have that problem in your calculator, negative 21 plus 9. You got to figure that out. And then you have 2 minus 3, which is negative x. And negative 21 plus 9 is negative 12. And then they're both negative, so you just drop the negatives off. But if you need to see how that's possible, you divide by a negative 1, and x is 12. Take that 12 and plug it into this spot right here. And 2 times 12, so it looks like this. Y equals 2 times 12 minus 9. Y equals, what is 2 times 12? 24 minus 9. All right, now do 24 minus 9 in your calculator. What is that? So if it's 15, what's my coordinate if I have a 12 and a 15? There you go. Over here, they're already done for you. Just go find where they meet. I'm not going to tell you that part. I'm not going to tell you what this coordinate is right here. You're going to do it. You're going to figure out what this coordinate is and then write the coordinate down. Okay? And hopefully you can do that. If not, you're pretty much cooked. But we can keep practicing and you hopefully have enough notes to help you. What do you do if you have something like this? You have to take this for x right here and plug it in right there. So 2 times 5y plus 1 minus 2y equals 18. And then now you're solving by distributing first. 2 times 5y is 10y. 2 times 1 is 2. Minus 2y equals 18. And then you're going to combine these two first. So 10y take away 2y is 8y plus 2 equals negative 18. Or just regular 18. I don't know where the negative came from. Regular 18. Minus 2. Regular 18 minus 2. 16. And then you divide by 8 on both sides. That's an 8. And the answer is 16 divided by 8 is 2, so y is 2. We're not done yet. Take that 2 and plug it in right there. So what is 5 times 2 plus 1? 5 times 2 plus 1, 10 plus 1, 11. X is 11. And what do I write if I have 11 and 2? I write 11, comma 2. Next, look at these and see if you find a match. No match. No match. 154. Oh, what are you going to do? No match. Now what? Will they ever meet? it looks like this is starts at 51 and goes up 3, so y equals 3x plus 51. And this one starts at 39 but goes down 3. Y equals negative 3x plus 39. We can plug those into each other and then find out if they meet or not. 3x plus 51 equals negative 3x plus 39. Add 3x to both sides. Subtract 51 from both sides. Cancel, cancel. 6x equals, what is this one? Negative 12 divided by 6 divided by 6. X is a negative 2. And you take that negative 2 and you can plug it in back to the original equation right here. 3 times negative 2 is negative 6 plus 51. So y equals 45. So they should meet at negative 2, comma, 45. Negative 2, comma, 45. Well, that should be on my chart then, right? And for all those who found that before all that, good job. You found a match. And the others, it's funny. Okay, down here, we're solving the systems. And we'll do a couple of them. You can do a couple more on your own. So this system, number 7, we just need one of these to be negative, and then that would be great, okay? So I'm gonna multiply a negative 1 in and change the signs on all the tops. Negative 2x, negative y, and negative 3. Then my 2x's cancel. My y is 2y minus y, which is just y, and 2 minus 3 is negative 1. So my y is negative 1. I plug that negative 1 back into one of the equations, 2x minus 1 equals 3. Add 1 to both sides. 2x equals 4. Divide 2. X equals 2. How do I write my coordinate down? I write 2 comma negative 1. That's the solution. These are great to practice for the test. I'll do number 10 here, and then you can practice on your own 8, and probably don't have to practice 9 and 11. There's not really going to be decimals and fractions, but if you want to go full expert mode, 9 and 11. But I'll do number 10, you try 8. So what do we have to multiply into the bottom one to cancel this 3x here? It needs to be a negative 3 times x is negative 3x. Negative 3 times 2y is negative 6y, and negative 3 times negative 1 equals 3. That middle equation's done. My 3's are crossed off, and I have 5y minus 6y is negative y, and negative 1 plus 3 is 2. And that negative needs to go bye-bye. So y equals negative 2. Take that negative 2 and plug it in right there. So 3x plus 5 times negative 2 equals negative 1. And this is negative 10. And add 10 to both sides. And you end up with 3x equals 9. Divide 3 on both sides, and x is 3. And the answer is 3 comma negative 2. And I would try number 8 on your own. Pause it here if you're going to do that. I'm going to skip 12. I'm going to move on to the next page. Wow, lots more to try. Good, these are great. Let me do 2 of them and you do 2 of them. Because you have to get really good at the standard form. You got it, you got it, you got it. You know what I'm saying? You got it. Okay. And my advice is to just cover and divide, cover and divide. But if you notice, like this first one, 23 divided by 3 and 23 divided by 4, it's not gonna work. It's gonna make decimals, okay? So if you notice it's gonna be decimals, you might wanna just solve for y, okay? Which is still gonna be getting some decimals. But all of these are going to create decimals, so there's really no way around it. So 23 divided by 3 is going to be a decimal. 23 divided by 4 is going to be a decimal. We could solve each one. We could just treat it as a system. Let's just not even do that, and let's just solve a system, okay? And let's figure out how to cancel x and y, okay? How do we cancel x and y? And I'll do 2 and then you do 2. These are like the hardest ones, the ones that like everyone was struggling with, because there's no simple move, and people like simple moves, but I have to get the x's to be something else or the y's to be something else. So a common denominator between 4 and 3 is 12. So if I want this to be 12, I would just multiply by 3, 3, 3, 3. But if I want this to be negative 12, I gotta multiply by negative 4. So now I have 2 new equations, okay? So follow me here. This is gonna be 9x. This is gonna be 12y. And this is gonna be 69. America's favorite, okay? This is gonna be negative 20x. This is gonna be negative 12y. And this is gonna be like negative 124. Someone check that, negative 124. So these cancel, and this is a negative 11x, and I'm gonna do negative 124 plus 69. Negative 55, which is perfect because when you divide by negative 11, you get x is 5. That's a beautiful thing. Now, here's the cool part. I do have 4 things to choose from. I can put 5 here, 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 or here. So I'm going to go back to the original. 3x plus 4y equals 23. 3x plus 4y equals 23. This is 15. This is 4y. This is 23. Subtract 15. Subtract 15. And that's 8. So 4y equals 8. And then you're dividing by 4. Divide by 4. You get y equals 2. And the answer is 5, 2. Take a look at that. Pause there if you need it. Let's try number 2. Number 2, you're just going to multiply a negative 2. Oh, that's actually interesting. Negative 2 in, but it's going to be negative 4 and negative 6y, which means both the x's and the y's cancel. And this is going to be negative 28, which means everything cancels. That's crazy. So when everything cancels, it's infinity. Okay? If x and y did cancel, and what's left is 0 equals 2, that's not true, then it would be no solution. But right now, 0 equals 0 is accurate, so. And you know what that means? That means any combination of x and y will be true and be infinite. So like, for example, if I chose 2 and 3, and then chose 2 and 3, I would make true statements. So it's fascinating. Okay. Next, this one's for you. You're going to multiply something into the top to get rid of the, you can choose -3 to get rid of this one, or you can choose -3 to get rid of this one. Uh-oh. Uh-oh. -3 is going to get rid of everything except this. See, it's going to make -9x done, -6y done. This is going to be -60 plus 36. So when you add those together, you end up getting 0 is -24, and it's not -24, so this is no solution. And if it's no solution, then what do you know about these lines? They're parallel lines. All right, do the last one. Hopefully it turns out pretty good. See if you can do it. It reminds me of the first one I did right here. So if you need to like pause the video on the first one right here and then do the last one on your own, try it, give it a shot. All right, those of you trying that out, go ahead. If you're skipping that, then I'm moving on. On the retrieval here, these are just more systems, and I'm not going to work on these ones, but you're definitely welcome to try it out if you want more practice. Here are some, this is actually on the test, single shading graphing. We can do these together, I guess. Okay. So make your X and Y axis. X and Y and X and Y. All right, so this is you dividing, and so 12 divided by 4 is 3. So y is 3, and if y is 3, then it's 0, 3, which is here. And then you cover this one up, and you say 12 divided by -6 is -2. So x is -2, which is -2, 0, which is located here. This is going to be a solid line because that inequality looks like that. Arrows on it, and then we plug in 0, 0, and see if it's true. Is 0 greater than 12? That's false. It's not greater than 12, so we're not shading on this side. We're going to shade on the other side. Grab your crayon, and it's just a regular shade. There you go. This one's going to be a dotted line. Don't forget, that's a dotted line. So 6 divided by 2x is 3, and 6 divided by 6 is 1. So y is 1, so x is 3, y is 1, 0, 1. So we're going to plot 0, 1, and 3, 0, and it's dotted. And plug in 0, 0. Is 0 less than 6? It's true. So we're going to shade with the origin. The origin's right here. All done. And a couple things to remember. Where to shade and dotted line, solid line, dotted line. Plugging over 1, dividing and solving for y. Plugging over this one, solving for x, right? Next page. much good on this whole page. I don't remember it. And then we get to here. This is great practice. I don't think I'm gonna do it, but you should definitely do it. So it's your turn, okay? And I want you to try to study this for your test and see how you do. And I will not be solving any of this, but I want you to practice it. I would stay away from the fractions. Just focus on plugging things in correctly and solving. That's going to be plugged in for y, so negative x plus x minus 1 equals 4. Like that problem needs to be solved. And then this is a system, so you can solve this system by multiplying both sets. I would multiply the top by 3 and the bottom by 2. And then that's going to change these, right? And what's it change it to? It's going to change it to negative 6x plus 15y equals negative 3, and 6x plus 4y equals 22. Those cancel. 19y equals 19. Divide 19. Y equals 1. I thought I wasn't going to solve it for you, but I am. Well, I won't plug the 1 back in. I'll let you do that, okay? And you can choose the first equation. And again, this is me not solving it for you. I'm not going to solve this one. Not solving it. Okay, and then you can write your own solution there. I won't write the solution. The solution is 3 comma 1, okay? But that's me not solving it. All right, so try, oh, this is a tough one. This is the one that got everybody on the quiz because they couldn't figure out, like, well, the equal signs aren't lined up. But what about the equal signs? That's literally a quote from someone. What about the equal signs? So x and y have to be on the same side, and this one has x on the right side, so we can just subtract 4x to get it onto the other side. Now that is negative 4x minus 2y equals 2. So all I did was move it over. I have a new equation right here. Now you can try to solve this by doing the regular thing that you always do, which I'm not going to help you with, for reals. Okay, over here, same thing we did before. Make it x and y, cover. This is a solid line, this is dotted. Okay, see if you can do it, try it, these ones are fun. Let's see, last page for you. These two are the same thing. When you cover this, right, it's gonna look weird, right, when you cover. There's a 1 here, okay? So when you cover this one, it's 3 divided by 1, it's just x is 3, so 3 comma 0. And then this is 3 divided by negative half, which is negative 6. So I did that for you, but you can plot those two, and then this is a solid line. So x, y, plot. All right. This one, you've got 2 things to graph. Graph them both. Fine. This is a shading. You can shade. It's a great test question. All right. Have fun.